Welcome to ASM and Chill with Chili. I'm Chili. You probably already knew that. If you didn't know that, I don't even know how you got here. It's kind of weird. I'm confused already. But anyways, in this series, there's going to be sirens blaring outside my window all the time. And I am going to be programming in assembly for my own shits and giggles, and you're welcome to come along and watch me. It's not going to be a tutorial. It's not a tutorial. But I will explain shit as the mood strikes me, and I'm going to narrate my thought processes as we go along. You can always ask questions on the Discord, on the forum, and on the places. But I am going to start off a little slow, just for my benefit and for your benefit. I'm going to dip it low, bring it up slow, roll it all around, poke it out like my back broke. You get the idea. So, what are we going to be working with? We're going to be working with DOSBox, because I like programming assembly under DOS. And the reason why I like doing that is because there are no limitations. The unknown is unattainable at Zombocom. That's backwards. But anyways, you get the idea. There's no, if you're running under Windows in 32-bit protected mode, it is protected. You got the kid gloves on. You can't touch this. You can't touch that. No. Bad executable. You go timeout. But in DOS, it's like you can touch anything. All the knives are out there. The gun closet is unlocked. I assume you have a gun closet because most of you are from America, right? Anyways, so what are we going to do? Well, we're going to double click. You're going to extract this. I'll put this on the Wiki page. You're going to extract that. You're going to double click on this and you'll get into DOSBox. And this is the, emulator for DOS. And it sets you up. It mounts a folder as C drive, puts you in the directory that you want to be in. TASM stands for Turbo Assembler. That's the program we're going to be using to assemble our source code. And it's good, I guess. I don't know. It works. It was fairly popular back in the day. I don't think it's around anymore. But, we're doing a little bit of computer archaeology here. We're going back and digging up the records. You know about the guy named Werner Vinge? He's a writer, science fiction. I like him a lot. Anyways, that was apropos of nothing. So here's our tools. This is where we're going to be assembling our shit, but that's not where we're going to be writing our code because I don't want to fucking do a text editor in a DOS window. That's bullshit. So my text editor is going to be in Notepad++, and I'll just drag my source files, or I'll save them into, basically just directly into this folder, and then assemble them in here. That's my workflow. So let's make a quick little program here. So we're going to put in some directives. .286. This is telling the assembler that we want to target the 286. Oh, I guess I should save this so I can get some syntax highlighting. So save as, and then we got to go to the desktop, and we got to go to the chili. Fuck. Where is my folder, you bitch? Oh, it's DOSBox. It's DOSBox chili, right? Not chili DOSBox. Or is it just DOSBox? It's just DOSBox. Okay. We're going to TASM. And we'll just call this one simple.asm. That's not how people pronounce that, but that's how I'm going to do it. People pronounce STD as STID, so I'm going to pronounce ASM as ASM. So we tell the assembler we want to target the 286. Why the 286? I don't know. It doesn't matter. You could target the 8086 if you wanted. I don't give a fuck. These things, I'm not going to explain them right now, but we want to do model tiny. You got a bunch of different memory models that you can select, or you can roll your own. This has to do with something called segments in 16-bit programming, and I'll talk about it later. It's not really important right now. So we set up model tiny. And when you're using these, it's called simplified model, or I don't know what it's called, but it's called simplified something. And when you're using that, you have to specify your data and then your code. So we're going to have nothing in the data segment, and now we have our code segment. And then you've got to specify a label. That's the entry point for your program. So first things first, we start 0100H. So we start assembling at address. It's actually offset, but whatever. Talk about that later, shit. So address 100 hexadecimal, and this is important and for reasons that I'll talk about later, I guess. So many things to talk about at the beginning, it's a pain in the ass. But anyways, so we want to start assembling our instructions at 100. And we're going to put let's put a label here. So we'll just call this one the start. We'll call it the start. Start is pretty canonical. I'm not even going to capitalize that. Just make it in it. Yeah, there we go. Start. And that's the start point. And then we can go end start. And the end tells you the end of the program, basically. I'll say that. And start tells it what the entry point was for this program. And that was start. So this will assemble into... Oh, there's the siren again. This is going to assemble into a program that does nothing. Well... Not quite nothing. It does something. We'll see what it does. But it's a program. And I should be able to compile this. Assemble this. Let's see. Let's see if I can assemble this. So, why did I do that? I already had it there. ASM simple.asm. It worked? Okay. Now, here's the thing. You assemble that, and you get an object file. I'm sure many of you are familiar with object files. They contain... machine code, but you have to link all of the objects that you program together into a binary, an executable. Although this time we're not going to link to an exe. We're going to link to something simpler called a com file. So we're going to go, let's go TASM, and we'll see our options. And I believe if it's down here, no, that's not it. And where's the option to create a... Well, I'm retarded. I was looking to link, and then I typed in TASM again. Fucking talking and typing is hard, man. Talking and typing is hard. Just try it. Try it, you fucker. All right, what do we got here? Okay, we want... What was it again? Want to generate a com file. It's not C. Of course it's not C. Why would it be C? That's dumb. Create a com file T. There we go. I believe the T stands for tiny because that's the model we're using, but I don't know. Who knows what it stands for? Could stand for your mother's a whore. There's a T in there somewhere, right? Okay, so we want to do T-link, and we want to go /T, and we want to go simple.object. Cannot generate com file, invalid initial entry point address. All right, so I put the org at 100. Start. And start. All right, maybe it doesn't like the fact that I have a program that literally has no instructions. So we'll add a token instruction in there, and we're gonna rebuild or TASM. TASM me. There we go. And then we want to link. Okay, it worked. Now this is going to be. I said this program does nothing, but it doesn't do nothing. It does something. Oh, it does something. Simple. It hangs the computer, so we can't do anything now. We are broken. If you're lucky, it hangs the computer. If you're unlucky, it does something really bad. Basically, because when you're doing assembly, like if you write a C program and you just write, your standard, let me just go here. You write your standard like int main, something like this, right? The compiler and the linker, whatever you want to do it, it's going to generate at the end of this, at the end of main, it will generate some nice stuff for you to return control back to the operating system. But when assembly, you don't get that. So what this program does is it loads this into memory, and it starts execution at this instruction. It executes the no-op, and then it starts executing the stuff after this, which could be anything, right? It's just garbage, or other programs or whatever is in memory. So that's not a good deal. You don't want execution to run outside of the bounds of your code. So what we're going to do is we're going to look at, I've got an old program here I wrote maybe like 6 months ago, and we're going to look at this. So this is what we want. So what is this? Well, interrupts are a way of calling system services. So under DOS, not so much under Windows, I would assume. I don't know. I don't do much. I mean, I haven't done any operating system development, so I don't know. But under DOS, you call interrupts, and that's kind of like your API. That is your interface into the operating system. And the reason why I use interrupts is because you can specify, for example, interrupt 21 is DOS services. And by doing that, you have this number 21 that doesn't change, but you're free to set the address of where the implementation is anywhere in the system. So it's an API, it's an application programmer interface. And we call these software interrupts to do stuff for us. And this one is, well, this one's DOS services. It does a whole bunch of shit. Let's take a look here. Okay, so int 21h. List of all interrupts in DOS int 21. What's this one? All right, this is the one I'm used to. So here we have a whole list of services that we can, have DOS do for us. And the way we select them, this is all int 21. The way we select is the value that we put in AH. So x86 registers. Let's see if we can get a list of. All right, so these are the main registers, the x86 16-bit. The registers are all 16 bits in size. And these ones here, the general purpose, are the ones you generally use for all sorts of calculations. It says general purpose, but they actually all have different agendas, different things that they're good at, that they can do, that they can't do. And it's kind of a pain in the ass, but it's also kind of amusing as in kind of puzzle. But anyways, so you got these general purpose registers, and these ones, you can address them also by the high byte and the low byte. So AX means the whole 16 bits, AH is the high 8, and AL is the low 8. These guys down here, we'll talk about these guys later. Lots of guys, but anyways, so what you do is in AH, you jam in a number, and that tells this DOS service what kind of stuff you want it to do. And if you jam in the number, what is it? If you jam in the number 4C, that's exit program, so that returns control back to DOS. So instead of your program, the CPU just continually executing garbage instructions in memory, it returns back to DOS and starts executing DOS again, which is probably a good thing. So we save that. And let's open up DOS again, because we fucked it. We fucked it hard. And we'll go dir, we'll go tasm simple.asm, and we'll go t-link/t simple.obj, and we'll go simple. And there you go. We have executed our program, and we returned to DOS. Mission accomplished. All right. So let's do something a little more interesting now. There are, in our world here, there are basically two kinds of software services that we're going to be working with. Software interrupt services. One is the DOS ones. These ones are installed when DOS is loaded. The other kind is BIOS interrupt services. And those exist on the BIOS chip that's on the motherboard. So they exist baked into a chip on the motherboard. And they're a bunch of lower level services than DOS services. If you look at this list here, most of these DOS services, a lot of them are about file access. Whereas the BIOS ones, they're more about lower level stuff. Like it's not about like open file, read file. It's like move the head of the hard disk to this sector or something like that. I don't know, cylinder or whatever. Don't ask me. I don't even want to touch it. But anyways, so let's look at a thing, shall we? BIOS interrupt 10H. That's the one we want. So interrupt 10 is BIOS services for video. And what we want to do is we want to be able to output a character. Write character only at cursor position. All right, I found something good here. In 10, which is, like I said, the video stuff, service E, or 14, will allow us to write a character in teletype mode. So AH has to be E, AL is the character to write, BL is the foreground color in graphics mode, and BH is the display page number in text mode. I have no idea about the display page number. It doesn't even say anything in here, I don't think. So I'm going to try to set it to 0 and hope for the best. So what we're going to do now is we're going to move into AH 0EH. That's hexadecimal, right? You have to put the 0 in front of the E, because if you don't, it just looks like a variable name, like a symbol. You got to put a 0 in front to let the assembler know, oh shit, that's a number. Okay, so now we want to do, what do we want to do? We want to move into AL, the character, which is going to be, let's see here, D. No, it's going to be a P. It's got to be a P. Then what we want to do is we're going to, BL doesn't matter, but BH. Move into BH, and we'll just put this big old 0 in there, because I don't know what it does, and I want bad things to happen. Then we're going to call interrupt 10 hexadecimal, and that should write a P onto the motherfucking screen. Change that order, doesn't matter, obviously. Save that. And where's my DOS box? Okay, so we'll TASM. We're gonna link that, and let's go simple. Give me a P. There we go. We got our P there. So the BIOS call has succeeded, and let's just fuck. Don't do that. No, bam, bam. Oh, there we go. P U B E S. Beautiful. Save that. And yeah, we'll TASM. Call T-Link. Oh yeah, and then we gotta run it. Simple. Pubes. Sweet, we did it. So there you go. There's a little bit of text output using int 10. And this is using BIOS. There's also functions in DOS to do text output, and it's a little more sophisticated, a little more high level. And of course, you can also interface directly with the video memory, which we might do in the future. We'll see. Now, one interesting thing we can do here with our, let's see here, with our assembler is we can make it output a listing file. So let's see, /L. So let's do that. T-assembler. Don't put an object after this. Why is that there? And now I'm confused. Stop that. There we go. Okay, so we want to make it generate a listing file. So put an L after that. And now we can open that up if we can find it. Maybe it's here. And a list, simple.lst. So let's put that in here. And what the listing does is it gives us the machine code and the addresses of the assembly language. So here we can see move 0E into AH. And so the opcodes for that, the machine instruction, is B4, which means move immediate value into AH, and then the immediate value comes right afterwards, and that's 0E. So in this, the value is embedded right into the instruction stream. And the same thing, so move into BH is B7, and move into AL is B0, and this is the ASCII code for P, this is the one for U, B, E, S, And CD is to call interrupt, and that's just, so this is calling interrupt 10 hexadecimal, and here we're calling interrupt 21 hexadecimal. So there you go. You can look at this, you can see all the bytes that come out of your assembly, and it's one nice one-to-one correspondence, because that's what assembly is. It's super dumb. So yeah, that's your listing, and if you don't believe me, you can take a look at it yourself. You can go into this folder here. Now we're creating a COM file, and the COM file, also known as a core image, is basically the simplest binary you can think of. All it is these bytes and nothing else. And when DOS runs this program, basically it picks a free segment and it loads these bytes into starting from offset 100 hex into that segment, and then it starts executing from 100. And so everything is fixed, and because the way it is, you can only load into one segment, which means your programs can only be 64K. 64K is all you get for your code and your data that's in the executable and your stack. Now you might be wondering, Chili, what the fuck is a segment? And I'll explain that later. It's pretty important for 16-bit programming under DOS, but we don't have to worry about it right now. So, like I was saying, if you don't believe me about this listing here, what you can do is you can go into a text editor. You can drag the COM file into there, and you can look at the bytes, and you can say, yeah, B4, 0E, yeah, B7. There's all the bytes. That's all there is. There's no, in a COM file, there's no metadata. There's no signature. There's nothing. Just the instruction and the data, if you have any. So let's set ourselves a slightly more complicated task. What we're going to do is we're going to be echoing characters that we type in to the screen. So let's search for BIOS boner. Why does boner come up? BIOS keyboard services. Int 16H. This looks promising. That's something that I was kind of expecting. Alright, let's try this one. Good. Wait for keystroke and read. Get keystroke status, get shift status, get... Alright, that's int 16 service 0. 0 on return AH is equal to keyboard scan code. AL is equal to ASCII character, or 0 if special function key. Alright, so what we're going to do is we're going to call, how's this going to go? Okay, so we're going to create a label here, call it loop, and we're going to go move into AH 00. It doesn't have to be hexadecimal, but whatever. And then we're going to go int 16 hexadecimal, right? I believe that was hex. Didn't say, did it? Didn't say though. Int 16. Well, could be hex. We'll find out. I think it says, yeah, here, 16H. Thank you very much for putting the fucking terminology. So this will block until we press a keystroke. And after we stroking our jerkin, yeah, we're gonna do move into AH, OEH, and BH shouldn't be a problem because it should still be 0 from up here. And then we're gonna do move. Do we have to move? We just have to int 10, right? And then we have to jump to loop. So now I'll jump here and we'll just infinite loop like this. This is useless, but keep it in just for the shits and giggles. And we'll just assemble that. Wait, reserved word. Fuck, can't use loop. Yes. All right, so that's a warning though. It's not an error. It's a warning. So we're gonna forget about it. But note to self, don't use loop, I guess. Whatever. Doesn't matter. Okay, so if we go simple, then we type some, yeah, motherfucking, we can type shit out all day long if I hit enter. Oh yeah, fucking carriage returns. Doesn't give a new line though, that's the problem. That's something you have to do yourself, I guess. But anyways, so that works, except it's infinite loop, so now our freaking program is hung. Our computer is frozen, in a sense, but it worked. All right, so what can we do here? Well, we could check. We could check to see. The problem is I don't know what the scan code is for, like, for example, escape. But I do know what carriage return is. So, okay. So, carriage return. Hex. What is it? Decimal 13. Close enough. It's decimal 13. So what we're going to do here, we're going to compare AL with 13 decimal, and jump, no, jump if equal to skip. And here we have skip. So if the button that was pressed was the return key, and we got a carriage return ASCII code in AL, then we're going to skip here. Otherwise, we're going to output it and then loop back up. How does that strike you? TASM, simple.asm, t-link, t, simple.obj, and simple, pubes, and press enter. Back in DOS. Beautiful. So that's how you do a loop. That's how you compare shit. We're doing all sorts of dumb bullshit now. All right, let's do something a little more sophisticated. We're going to go into DOS interrupts, and we're going to write a string to standard out. So now the weird thing about DOS and the string command is you have to terminate the string with a $sign, which means the string can't contain a $sign. It's fucked up. Why did they pick the $sign as the terminator? That's weird. But anyways, so what we do is, all right, so we need to have a string in memory, and we're going to give it basically a pointer to that string and the beginning of the string, and then it's going to output that to the motherfucking screen. So we're going to have to set DX, and that's it. It should be very simple. Now we need to be able to set up our string in memory, so we're going to use data. Now there's a directive, and let me just find it out here. I don't want to have to search for it. Directive is called define byte, and it allows you just to put numbers into memory. Shit. I said data here, but we don't actually have data. We have to put the data starting at 0100 because, yeah, the program will start here. So we can't put our data at the front. So we're going to put our data at the end of the program. It doesn't matter where we actually put the data. We're going to put it here. And I'm not sure if we can put it after the end, but I'm going to try to put it after the end. So we're going to go my string. That was weird. It was supposed to be like Borat, but it ended up kind of gay, like a gay Borat. And you could just put, like, if you look at this thing here, single quotes and string seems to work fine. So that's what we're going to do. Single quotes and pubtastic. No, wait. My wife. That's a little better. my wife, and then let's put in carriage return and line feed, which I believe are these guys. And last but not least, we put in the terminating $sign. All right. So what'll happen is when the assembler sees this, instead of doing like what it normally does and converting, assembler instructions into machine language, it's just going to take these bytes here and put them into memory as is. It's going to, in the ones in single quotes, it's going to convert from ASCII into, just the values. And in here, it is going to use these numbers and put them directly into memory. But you get the idea. So, do this, but now we're not done. Now we want to motherfucking call that guy. So, the way it works is... So forget about this. This is the segment, and it's already pointing to where we want, so we don't have to worry about it. Talk about this later. But DX is the offset, and this is basically the address of the string. So we've got to put the address of the string into here. So what we can do is we can do this a number of different ways. But what I'm going to do is I'm going to go move into DX, the offset of my string, and that will move the offset, basically the address of this string, into DX. Then we're going to move into AH, and we got to get the number of this service, which is 09H. So 9 hexadecimal. And then we're going to go into 21H. And this should output a string and give us a carriage return. My wife. And then we'll get pubes, and then we'll get our keyboard bullshit. Save it. So, again, we're gonna assemble this and allow me to generate a listing there. Wait, undefined symbol my string. Oh, okay. All right, that's fine. That's fine. All right, what if I move this inside of the start? So maybe it doesn't like it if it's outside the start. Let's do that. And we'll save that. And we'll run that. Alright, it worked. Warning message past 1. Good? Good. Okay, now if we go... Shit. Let's go to T-Link. And... simple.obj. That's wrong. It's got to be tiny. There we go. And then we go simple. And there we go. My wife, pubes, and then we can type to our heart's content. Beautiful. All right. Yes, I understand. So if we look at the listing file here, and we got our code here. You don't like that. Good. Now, at the defined byte portion here, my string defined byte, my wife 1310 blah. All you're doing here is you're just taking these characters and you're jamming in their ASCII numbers into the program, basically. There you go. And that's how you do. And this is how you get basically the address of some symbol. You offset in front of it, and that gets the address of that, and then I'll move that into DX. It's actually called the offset, but again, that's a story for another day. All right, so for our final task for the day, what we're gonna do is we're gonna input a string from the user, and then we're gonna convert that string to a number. So we're assuming the user is gonna input a number, and then we're gonna print out pubes that many times. So first things first, let's let's input a string. So we're gonna go buffer define byte question mark. And what this does is this basically sets up a symbol for us. We're not setting the memory here to any value, but we can get this offset here. So basically what we're doing here is the memory space after my string is where we're gonna store the input from the user. So we need to know that address. So we do this define byte here so that we can get the offset of the space after my string. So in here we're gonna go pubes exclamation mark space, and here was our buffer for the input. Now what we want to do, let's get rid of this. Let's get rid of all this garbage here. We're gonna clean some house, motherfuckers. And we'll get rid of that. So first things we want to do is we want to input a string. So we're going to use DOS for that. And let's see if I can find it. Here we go, buffered input. So again, we do offset into DX. And see below. Offset 0, size 1. Offset 1, number of cars. Okay, this is weird. So the pointer to the thing that we do, the pointer that we pass to this interrupt service routine, it's not a pointer to the buffer. It's a pointer to some data that includes the buffer. So the first byte in this pointer is going to be the maximum number of characters. And the second byte is going to be the number of characters from last input which may be recalled, or number of characters actually read, excluding CR. I don't understand this actually. I think it might be... Shit. What the fuck is this anyways? Buffered input, write string. Number of characters from last input which may be recalled. Or number of characters actually read. Okay, so I think this is actually written by the interrupt service routine. And it's the number of characters that are in the buffer. And then starting from 2, we get the actual characters read, including the final carriage return. So what we're going to do is... Alright, that's fine. That's fine. So we just got to keep this in mind, that our buffer character starts from here, and it's including the carriage return. Here's the number of characters read. We'll see. We will see. This is fucked up. Who designed this shit? Microsoft? Of course. Alright, so what we're going to do is we're going to go move into DX, the offset of buff. And then we want to go move into AH. And what was the number for that service? A there by. So we're going to go OAH. And so this, and then we're going to go int 21 hex. So this is going to fill our buffer with input from the user. Now we got to convert this into a number. So we're going to, for simplicity's sake, we're going to assume that the input is valid. It's a number. And we're going to assume that the number is in decimal. So what we got to do is we got to divide by 10. First we've got to get the modulus for 10, and then we divide by 10. And we keep doing that until it's 0. So, no wait, that's if we want to convert into ASCII. No, it isn't. What is it if we want to convert from ASCII into, we got to multiply by 10. All right, I got my head screwed on backwards there. So, but we have to count the number of characters in, but we don't have to count it because it's already in there, probably. If I understand this correctly, this will be the number of characters. So we can use this to determine how much we have to multiply. Or do we start backwards? All right, this is already getting way complicated in my brain. So we're gonna have a buffer, and let's just go first place, second byte, third byte, fourth byte, fifth byte, sixth byte, and so on. So the first byte is going to be the number of characters that the buffer can hold. We set this value, and let's just set it to be, I don't know, 10. Doesn't matter. Next one is going to be the number actually written. So let's say we enter a number like 2, 3, 1. So this is going to be 2, 3, 1, and then the carriage return, which is 10. And this one is then going to be the number of characters written minus the carriage return. So this one's going to contain 3, and this is written by DOS. This part is all written by DOS. This is read by DOS. All right, so far so good. Maybe. Yeah, I think so. So now what we want to do is we go through these guys. All right, I think I got this. So we add 2. So we start off with 0. 0 plus 2 is equal to 2, right? Then we check the next one. Is it a carriage return? No. So we multiply this by 10, 20, and then we add 3, 23. We check the next one. Is it carriage return? No. So we multiply by 10, we get 230. And then we add 1, we get 231. We check the next one, is it a carriage return? Then we stop. Okay, good. So we don't even have to read this. That's not important. What is important is that it's terminated by a carriage return, ostensibly, unless it goes to the whole, but we're not going to worry about the buffer size. We are assuming no bad inputs, because I don't want to deal with that bullshit. It's not the point here. The point is to get something that does a thing. Not to create something that's bulletproof, because I don't fucking care. So, what we're going to do then is, so we got our stuff now. And if the data is where I assume it to be, what we want to do is we want to move. Let me think here. So we're going to go BX. And do I want to go BX or do I want to go DX? So we're going to move DX offset of buffer plus, where's my plus sign? Plus 2. So I think I can do this. Sometimes I forget my what addressing modes I can do. But I think I can do offset of buffer plus 2. We'll see. If the assembler hates it, the assembler hates it. So we start off there. And then we got to test. So. Compare. We're going to move. No. We're going to compare. The value pointed to by dx, and that's what these square brackets are doing here. So the value at the address dx, or the offset dx, compare that with 10. And jump if equals to done. And here's where our done is going to be. There we go. All right, now, so if it's not that thing, then, so AX, first off, XOR AX. So if you exclusive OR something with itself, that's just zeroing it out. We're clearing AX. This is where we're going to accumulate our value that we're parsing. So then add 2AX, the value at dx. All right, but first we have to multiply the thing that's in ax by 10, right? Because remember, we multiply by 10, then we add. Multiply by 10, then we add. So this is 0 times 10, 0 plus. There we go. So what we got to do is multiply by 10. Now multiplication is fucked up. We can do it by bit shifting. But let's do multiplication because it's interesting. So x86 mul instruction. Unsigned multiply. That's what we want. All right. So multiply register and memory 16. What do we got here? I'm not sure if we can do an immediate mode multiplication. Performs unsigned first operation and the second is source. It stores the result in the destination. Destination is an implied operand located. Okay. So yeah, the destination LAX or EAX, depending on the size of the operand. Destination operand is located in the action of this instruction and the location of the result depend on the opcode and the operand size are shown. So fucking bullshit. Okay, so here it is. Source 1 AX. Source 2 register or memory 16. Can this be immediate? I'm hoping it can be immediate. So we multiply AX by something, and the result is the high part is in DX, the low part is in AX. Now we don't need the high part because we're not dealing with values over. We're not dealing with the bullshit. We're not dealing with your bullshit here. So result is going to be in AX. So it's actually super easy. All we got to do is multiply AX by 10. I think this will work. If it doesn't work, we'll use a register, but I think that'll work. All right, so we'll multiply by 10, and then we add. Then we have to increment the pointer. So increment, shit. DX gets written over. Fuck me. So this multiply instruction writes to DX. So change of plan. What we're going to do is we're going to move into BX. So BX, and I believe we can use BX for this purpose. And then we add, what is that BX? There we go. And then we want to increment BX. We can't, like I said, we can't use DX because multiply stores the high part of the result in DX. So it'll overwrite it whenever we multiply. And we want to keep our pointer because we're incrementing it every iteration here. Now, we want to jump to parse. So we don't do that. We don't do that. This is initialization. So here's our parse loop. And we compare. And if we're done, we jump out. Otherwise, we multiply, add, increment, and then we go back up here to do the comparison again. I might be able to reorder this loop to make it better, but I don't fucking care. Don't fucking care. So, now we have our result in AX. What are we going to do with it? Well, we want to output pubes that many times. So, first off, we need AX to call interrupts. So, shit. Maybe I should have used CX. Why is that capital? Stop that. So I'm gonna change this to CX. Where is the other one? CX and CX. I believe all these operations can be done on CX as well. And we're gonna leave AX because we're gonna need it for something else. Now, we want to output. We want a loop of outputting. We're not gonna call this done. We're gonna call this P loop for pubes loop. So we'll do that. And in the P loop, what we're going to do, we're kind of making an assumption here. Because because I'm assuming that the count is going to be greater than 0. That's a big assumption, but I'm going to do it. So what we're going to do is we are going to output pubes, which means we're going to move dx offset my string. I feel like chicken tonight, but I also feel like maybe we don't need, yeah, we don't really need to redo this every single time. So jump parse increment bx. Yeah. All right. So what we're going to do here is we're going to go back to done. Trust me. This is done. So many jumps here. This could be optimized, but I'm not in the mood. I'm not in the mood right now. You know what I'm saying? I'm not feeling it in my feels. So what we're going to do here is we're going to go move. So we set up dx. Now we set up AH to, what is it? 9 hexadecimal. And now we go pube loop. So now we can call interrupt 21 hexadecimal. And then we can decrement CX. And then we can jump, if not 0, to pube loop. So we keep decrementing and jumping if it's not 0. And we're just outputting this string. So we shouldn't have to set this up. We shouldn't have to set this up. They should be the same. And then we exit, right? So when CX becomes 0, we quit. We say, fuck this shit, I'm out of here. All right. So I'm not sure if this works. I'm not sure if some other stuff works, but this is what we're going with. We'll save it. We'll go into TSM. Error message is 1. Argument needs type override. Extra characters online. What's 18? Fuck, stop that. 18 extra characters online. Multiply. Right. Okay. So, multiply always works on AX. So we can't use CX. That was dumb. Why I even talked it out and I was like, this all works with CX. We can use CX. We can't use CX. Of course we can't, because multiplication only works with AX. So multiply 10, and we just write 10. We don't write AX 10 because it's implied that we're multiplying AX by something. So we just have to write what we're multiplying it by. All right, so AX, BX, yeah, probably okay. Now, what we do here is we move AX now into CX. And then we set AH up, and Bob's your uncle. That'll work, right? What's the other one? Argument needs type override 16. Yeah, we want to compare the value pointed to at, it's got to be, byte pointer. So I think this is how you do that. Just can't remember. But yeah, because we're not sure, because we don't know the size of this thing. It's just a literal. It doesn't have a size specifier. We don't know if we should be comparing the byte pointed to at by this to this, or we should be comparing it as a word or what. So fair enough. You got me. Let's try. Argument needs type override. I did save it, right? Yeah, I did save it. Okay. Illegal immediate. All right. So we can't do this. So what we got to do is we got to find something that we're not using. move into CX at 10. And then we're going to multiply CX by AX. How do you like me now, bitch? Or argument needs type override. Okay, this could be big. Maybe I can use immediate. Because remember, there's multiple versions of multiply. Some of them work 8-bit, some of them work 16-bit. Let's try the one that works. Let's go... Fuck, can we go byte? That doesn't seem right, though. Does that work? I've never done that before. I've used byte pointer, but I've never used just byte. Nope, doesn't work. Okay, you know what? I might be possible. Wait, why did I do that? That was supposed to be multiply. Okay. We are approaching the end of the session where I'm going crazy. Illegal immediate. Okay, good. Fine. Stop doing that. Oh, I fucking hate it. So what we're going to do... Now, there might be a way of doing this, but I'm not sure. What I'm going to do is... move into CX. Move 10 into CX. Multiply CX by AX. Alright. Actually, we're not changing CX anywhere in here, so we can do it up here. Like this. Set up CX with 10, and then we just have to multiply CX by AX. Does that sound like a deal to you? Because it sounds like a deal to me. Alright, it worked. Done. Now let's link it and see that we're probably going to fail, right? So, because I have absolutely no faith that I'm interpreting this documentation correctly. I should probably... No, that's just this. Yeah, I don't trust it. Anyways, simple. Wow, that was not what I was hoping for. You know what I mean? It's not what I was hoping for. Not at all. Let's not do that. Alright, first things first, I'm Bear Grylls, but also, we kind of fucked it up because, well, when I say we, I mean mostly me. Because this format of the DOS input buffer, we're not really following that format, are we? 1, 2, 3. Yeah, that's not correct. We should have put in here. So I should put, and let's just say it takes, I don't know, 20 characters. And yeah, so this is the size of the buffer, and then the byte that comes afterwards will be the number of bytes written, and then the bytes that come after that are the actual characters. Now, move BX. Okay, this is fine because this is what we're reading from. Let's try this. Okay, so far so good. It hasn't shit the bed completely. Now let's type some characters out. So we want a number. So let's type in 10. All right. Okay, that wasn't good. Well, I mean, that makes me sad. All right, I've figured out one more error here, one more bug, but it's probably not causing the thing that we're seeing. But yeah, we're adding the thing pointed at by BX to AX, but AX is 16-bit wide. This is actually adding 2 bytes. And the other problem is that we're not fucking converting from an ASCII digit into a decimal digit. So, lots of problems here. How are we going to solve them? Well, first off, we have one register open, and that is DX. No. Yeah, it's open here. That's fine. DX will be fine. So, what we can do is we can go move into DX into, what are we going to do here? XOR will clear out DX. And we're going to move into DL from the thing pointed at by BX. So we're going to move a byte into DL. That's the character. Then what we're going to do is we are going to subtract from DL and the ASCII code for 0. And this will convert it into just a number if it's between 0 and 9. If it's another character, it'll be garbage, but that's fine. Then we're going to add DX to AX. And because we exclusive OR, the high part is 0. The low part will contain the value of the digit, and that'll be added in there. Then we increment BX. We do the thing. Here we're comparing byte pointer with 10. And that should be okay. If the buffer is the way it should be, the way I think it should be, the way I want it to be, this would be okay, but I don't think it's actually going to work. All right, so now we get to the fun part, which is trying to debug a program. And this, we're going to use a very primitive tool here, the original debugger, debug. And we're going to debug simple.com. Why is there a simple.exe? That makes no goddamn sense. All right, simple.com, let's go. Me and you. Okay. What are the commands? D. All right. So I don't remember what that does. This is the memory, I guess. This is what is in the memory. So this was disassembly? That's not it. All right. Instead of trying to remember, no, is S for step? No, G is for go. Debug.exe commands. All right, debug. This one? Yep. Nope. Is there a list of commands? List of no, that's not it. Fuck. MSDN. There we go. You wrote the program. Oh, sweet. We got a whole bunch here. So D is dump, right? Took a big steamy dump on this one, that's for sure. So what is step? Is that T is trace? I believe T is the one we want. So what is the registers? Is it R? Register. All right. So here we've got the contents of the registers. All right. Let's look at our disassembly here, our listing. And this is how we do it. 132. Right, 1, 3, good. So, now first instruction is move 139 into DX. And 139, wait, what? 132, 139. 130, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is this out of date? Ah, this is out of date. Okay. Never mind. Quit. Abort. So TASM/listing simple.asm. That was an old version that I had in here. There we go. Reload it. Perfect. Now it's 139. That's the offset of the buffer. That's what we want. Debug. Wait. It's still in there? Yeah, it is. Okay. So, registers. Good. Let's trace. So we move 139 into DX. Like so. Then we're going to move AOA into AH. Trace. No, not there. Fuck off. Trace. Then we call int 21. I'm gonna dump. Okay, I got a whole lot of garbage here. But pubes, where's my 20? So here's my 20. 21 is the exclamation mark. So 20, this is the start of the buffer. And then here's all the garbage after that. Okay, so what we want to do is we want to see what what happens to this after we leave this interrupt. So we go. Fuck. Can I do keyboard input while I'm in the disk debugger? Oh, now I don't know. Now I'm done. Second guess myself here. Yeah. Set interrupt flag. Don't know. Okay, here we go. We can do keyboard input. So let's type in 120. 120. Do it. Okay, return from interrupt. So it's done the input. Ah, okay. Yeah, trace that. Okay, exclusive or AX. So we return from interrupt. We're now clearing out AX. Let's dump. Okay, here is what we get. Where is my stuff? Fuck. No, I don't want to dump this one out. Shit. Okay, we need to dump from a specific memory location. Dump range. Specifies the starting and ending addresses or the starting address and the length of the memory area. Examples. Dump 110F. I don't know. Wait, what's DCS? I'm gonna use the D command. Fuck. Okay. Let's just try stuff out. Dump. Where is my shit? My shit is at, so the buffer starts at not 130, 139. So let's dump starting at 130. So dump 130 to, I don't know, 150. Good. So 20, 14 hexadecimal. This doesn't make any sense. This doesn't make any goddamn sense. Because there's the 120. There's the 120 that we input. My God. Oh, OD. OD. I'm about to OD here. I'm about to give you my D. Because OD, okay, so it said carriage return. Which one is carriage return? No, it said carriage return, but this is line feed? No, wait, carriage return is 13, and I put, okay, so I'm an idiot. All right, that makes sense. I mean, I'm always up for the explanation that I've been an idiot. It's basically, par for the course. So this should be D, which should be 13. This is the thing that we should have been, okay, now we want to make sure, I shouldn't have exited out of that so quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see this? There are 2 bytes before it starts its bullshit. That's not acceptable. I don't understand why there should be 2. This one is the size of the buffer. This one is what is this one? I don't understand what this one is. It could be anything. We are ignoring this one because I have no fucking idea. But the one after that is the actual number of bytes written. That's 3 of them, excluding the carriage return. And then this one is the character. So, okay, so we did this. We got this fam. +0, +1, +2, +3. So we're going to offset +3. We're going to stop at this one. We're going to subtract here. It's all good. This is going to work. I am 100% no chance of failure. All right. Do it. And you are going to complain. Yes. And okay. Looks good, I guess. I don't know. And then we're going to link it. Can't link it. Okay. We're going to link it. Link simple.obj. And Then we are gonna do what? Smack my lips. And then we're gonna go simple. We're gonna pray. We're gonna type, we want 5 pubes. Fuck! Okay. Okay, we're gonna relax. We got this. We're good. We're gonna handle this. This is not going to let us, it's not gonna get us down. I get knocked down, but I get up again. DIR. Alright. Debug. Simple.com. Right? Yeah. Trace. Yeah, that's good. Okay, so we'll move the offset into there. We do the thing, we call the interrupt. Stuff happens. We type in a number. We type in the number 20. No, 20 is a bad number. 69. No, that's not hexadecimal. What's 69 in? I don't know. Fuck. Why did I make it decimal? We'll type in 15, because that's an F. An AF. And then we're going to trace. Okay. Now we're going to dump. Okay. Now we're going to look. 15, there it is. 15. And there's the 0D, which is 13. And yeah, 0, 1, 2. I don't know. I'm scared. But yeah, it seems right. See, everything seems right. And then it doesn't work. And that's where I'm sad. That's the part that makes me sad. So we're gonna move A into CX because that's 10. And that's what we're gonna multiply by. We're gonna move 13C, dump 013C. 013C. 35. That is the start. No, that's not the start. Fuck. Motherfucker. Why is that not... Offset buffer plus 3. So the buffer is at 139. Plus 1 is... Fuck. This is hexadecimal, okay. Plus 1 is 13A, 13B, 13C. Right. So why is that not here? Fuck. Plus 0 here. Plus 1 here. Let's go D. Shut up. Dump. Maybe I'm just using the dump command wrong. 0, 1, 3, 0 to 0, 1, 3, F. All right. 0. Shit. Doesn't even line up. My eyes are killing me. 0, 1, 2, 3, 4, 5, 6, 7, 8. 8? Wait. 9. I did it. Right. This 20 is the space. This 20. Right. This 20 is actually 14 in hexadecimal. So the 14 that I was saying, what the fuck is this? That was 20. And so that means that this is correct. This is correct. This is the 14, the 20. This is the thing, the 2 that was right after. This is the, okay, we're good here. We're good. I'm starting to learn things here. So this was okay. This was a 2. That was fine. Save that. Fucking bullshit. Then we're gonna quit. dir. All right. We're getting this. We are gonna fucking kill this motherfucker. So TSM, yeah, we'll generate the listing, simple.asm. Good. Then we're gonna go t-link and what was it again? T simple.obj. And then we're gonna go debug simple. Do I even test fate? Do I even test fate? Yeah, let's try it. That's not gonna work, but let's try it. Yeah, it didn't work. Wait, but it did actually go back to DOS for some reason. I don't trust DOS anymore. I think I might have corrupted it. Yeah, okay, whatever. All right, so debug simple.com. All right. So trace. Put in a 15. Return from interrupt. All right. Dump. There we go. All right, so we got 15. We got our carriage return. We got our 20, our 14, which is also okay. We got our 20 here. This is our 20. This is the number of characters written. Yes. Okay, we're good. Now, let's get our fucking list up here. Why is the fucking the tabulation is bad? All right. Moves A into CX. Move 13B into BX. 13B 8 9 A. Wait. This is 8. This is 8 9 A B. Correct. Okay. What's after that one? Move BX into move. Okay, that's good. Now compare BX with 13. Yes, compare byte pointer BX with OD. And that's 31 is not equal to OD. So we're not going to jump. So we're going to go to the next instruction, which is multiply CX. Now, CX is that, but AX is 0, so the result is going to be 0, zeros in AX, and zeros in DX. Correct? Correct. Okay. Now we want to clear out DX. Not necessary, but we did it anyways. Now, we're going to move the byte pointed to a BX into DL. Now that byte, 31, which is ASCII for the digit 1. Do that. Now we're going to subtract 30. So now DL contains the value of the first digit, which is 1, which is correct. Now we're going to add that to AX. Now we're going to increment BX. Now we're going to jump back. Now we're going to compare. Is it the thing? No. Now we're going to not jump. We're going to multiply by 10. We're going to multiply AX by 10. Result is hexadecimal A, which is 10. We're going to clear out DX for no good reason. We're going to move the next byte into DL, which should be the digit 5. We're going to subtract 30, which is the digit 0. That, and we're going to add that to this, which should give us 15, which is F. And AF, we're going to increment BX. We're going to jump. We're going to compare to see if it's D. It is a D, so that's a carriage return. And then we're going to jump to here, the address 122. And we are at address 122. And now we're going to move. Okay, so this part works. This works now. This works. This works. This not working. Not working for me. So why is it not working? Well, Chili, did you maybe forget to put a fucking terminator on your fucking string? I mean, you might have forgotten to put a terminator on your string. I don't want to, I don't want to jump the gun. Maybe you want to terminate your string. Because if you don't do that, shit's gonna fucking, it's not gonna be good for you. That's all I'm saying. Alright, I know, now I think I have the lay of the land here. Just don't fuck with me anymore. I'm tired of your bullshit. T-Link. And T simple.obj and simple.com. There's an exe in here too, right? For some reason. EL. I don't know how that got there. So we'll just type simple. We'll type 20. I didn't save. Wait. Fuck you. I didn't save this. I didn't save it though. So that was a waste of time. I don't really trust this, but I'm gonna run it anyways. Because I don't want to do this over again. So, assemble. Seems to have worked. Link. Turbo link. Seems to have worked. Okay. Simple. Please just work. Yes! Finally, we have defeated my own stupidity. Simple. 400. Yeah, it's a lot of pubes. 69 pubes. There you go. Alright, so. Yeah, so I think that is enough for today. I had enough of this. I mean, it's all my fault, but still. I enjoyed it thoroughly, and at the same time, I've had enough for today. But yeah, if this hasn't turned you thoroughly off to assembly programming, then stay tuned for more, and it will be coming, and I will be coming too. Now, yeah, if you have any questions about this bullshit, feel free to ask again in the Discord, in the forum, in the places. But yeah, I'll see you soon.